Hi, my name is Jessie Jobson, and I am a fourth grade math teacher. And I'm actually coming today because I wanted to talk about word problems. So, I don't know about you, but my first year teaching word problems, I really had no idea where to begin. Like, I knew we needed to talk about them, but in my head, the most important thing that I had to teach were the operations. Once they knew the operations, in my fantasy world, the kids were just going to get it and soar, and we had no problems. The problem really kicked in where I realized that while in my head they were going to do fine, when it came down to it, they didn't know when to use an operation. So even though they could multiply beautifully, they didn't know that they should be multiplying. And so I had kids who were adding or subtracting. They were pretty much just kind of guessing. Like they would look at a problem and say, oh, well, I want to add today, so that's what I'm going to do. And that became a huge issue because it became very apparent in my tests that I wasn't teaching prob- like problem solving skills for how to solve a word problem. I hadn't given a structure for the kids to work through it. So then I went, okay, well, what have the kids seen before? And so the big thing that the kids had seen before was actually called cubes. So you can kind of see that up in the back. It's a story problem solving strategy. This is just a picture that I found off of Pinterest. It's not mine, but it's got circle the numbers, underline the question, box in the words that are key words, eliminate information not needed, solve by showing your work. The bones of this strategy are great. The problem is right here with the third step, box words that are key words. I teach fourth grade. Really, through third grade, keywords work really well. There are the same types of phrases and keywords that pop up that are always used to indicate what type of word problem is being given. However, when we get to fourth grade, we run into the issue where they will intentionally use keywords on state tests at the end of the year. They will intentionally use keywords that are not actually indicating that operation. So they might use a keyword for addition, but then the question is actually subtraction. And the kids were living and dying by keywords. And so even when we were working on these word problem skills, they were still getting them wrong. Now, this isn't to say that I don't have keywords up in my room. They are a good strategy, but they can't be the only strategy. It can't be all of your eggs in that one basket because that's when the kids start to really struggle. They're not picturing what's happening. They're seeing the word combine and saying, okay, we're going to add. So in my classroom, I do actually have keywords posted. I actually keep them closer to the back of the room so that they're there for the students who might want to look back as a refresher. But I don't keep them front and center because they're not what I want them to see first thing. So, all of that background to say, I want to show you today the strategy and the method that I use for teaching word problems. It really boils down more for me about questioning. This is the problem we're going to go through. So it says, each cookie Luanda's mom bakes must have 9 mini M&Ms on top. If she has 922 mini M&Ms, how many cookies can she finish? So for this problem, the first thing I have my kids do is write the word no. This is where we're going to write down what we know about the word problem. This is where we put facts. And so when I'm teaching my kids about how to find facts, one of the big things we do look for are numbers. We go sentence by sentence and we look critically at the information. Is it something we need to know to mathematically solve the problem? If they tell you that a person's birthday is April 28th, but they're asking about the total number of shoes the person has, then their birthday is a great fun fact, but it really has nothing to do with the mathematical final answer. So, sentence by sentence, each cookie Luanda's mom bakes must have 9 mini M&Ms on top. That means you need 9 mini M&Ms per cookie. That's one fact. Then we move on to the next sentence. If she has 922 mini M&Ms, how many cookies can she finish? Now this one, they actually took a fact and the question and they kind of put it together. So we're going to pull out the fact first. The fact is that there are 922 mini M&Ms. So we're going to write 922 mini M&Ms. There are no other facts in this problem, so we're going to go ahead and move on to the question. The question is, how many cookies can she finish? How many cookies are finished? So that's it for breaking apart the problem. We write down what we know, we write down what we want to know. We actually use both of those pieces in the next couple steps. So now that we have that, we're going to write down how to solve. We start out our how to solve category by picking an operation. So I have my kids call out what the different operations are. There are only 4. We practice this a lot. I use that word operation because a lot of times in North Carolina, they do see that on a state test. They'll have the word operation there. And if they've never seen it, even if they know the 4 operations, not seeing that word is scary and it can cause some kids to shut down that know the answer, but they got freaked out by the word operation. So we've got add, subtract, multiply, divide. So now that we have our 4 operations picked out, there are 2 big questions. So the first big question that we're going to use is the question, and my kids don't write this down. This is what I ask them. So I'm going to put that on a sticky note because it's what I would say, not what they're going to say, or not what they're going to write. So it would be, do we know the total? Do we know the total? That is the first question. If we already know the total, that means when we look at our facts, if the total is given to us by the problem already, we can eliminate 2 operations. If we have the total, we can eliminate addition and multiplication. We use addition and we use multiplication when we want to make the total. We're trying to make a bigger number. So if we have the total, we don't want to make a total. If we do not have the total, then we want to make it. So we use that question to guide our thinking. In this case, 9 mini M&Ms per cookie. That's not a total, that's a piece. 922 mini M&Ms. That means like the bag they have has 922 mini M&Ms. That is the total. Because we have the total, we don't want to make it. So we're going to get rid of addition and multiplication. I like to point out right there that our kids have doubled their chance of being correct with one step. They haven't even solved it yet, but they've got double the chance of being right. So that leads us to our next question. The next question that, remember, I ask, the kids don't write this down, but the next question that I ask is, are we working with equal groups? Are we working with equal groups? And so we're going to take this part right here with equal groups, and we're going to go back, and this is where we reread the problem, but we really focus in on trying to see it like a movie. So in this problem, we've got each cookie Luanda's mom bakes must have 9 mini M&Ms on top. So we're going to go back, and we're going to picture somebody in the kitchen baking cookies. I picture out like somebody like counting out the little M&Ms. We need 9 per cookie, so we're going to add them right on top, squish them into the dough. If she has 922 mini M&Ms, so I'm picturing that big bag of M&Ms, how many cookies can she make? And so that person has put 9 M&Ms into one ball of dough, and then pulled another ball of dough, 9 M&Ms into the second. They're going to keep going until they run out of M&Ms in that bag. So I could subtract. I could take 922 minus 9, minus 9, minus 9. I don't want to subtract 922 who knows how many times though. I could. Mathematically, it would be correct. But we know that the more times we have to do an operation, the more likely we are to make a mistake. So it could be repeated subtraction. But we're talking about equal groups. And so because we're talking about equal groups, we want to do division. We don't want to do equal groups of repeated subtraction. We want one division problem in and out and we're done. So that's how I would walk my kids through the thinking. So, okay, we've picked our operation. Now we have our numbers. We've got 922 divided by 9. That would be the equation we want to solve. So I'm going to come over here. I'm going to set that up. Ooh, there we go, 922 divided by 9. We're going to need to write our quick facts. So our quick facts, for those of you that are unfamiliar with this strategy, quick facts are just math facts that are easy for us to recall. And so 9 times 1 would be considered a quick fact. 9 times 1 is 9. 9 times 2 would be 18. 9 times 5 would be 45. 9 times 10 is 90. 9 times 20 is 180. 9 times 50, if we're not sure, we go back to 9 times 5, so that was 45. With 1 0 at the end. 9 times 100 is 900. We're getting close. 9 times 200 is 1,800. Okay, so there we have it right there, all of our quick facts. Can I do 922 minus 1,800? No, that's too big, so we're going to cross it out. Can I do 922 minus 900? Yeah, we're going to write 900 here. On the side, we're going to write the 100. Our 9 is already up here. So that would leave us with 22. Can I do 22 minus 900? No. 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 Getting closer. 22 minus 45. No. 22 minus 18. That we can do. We're going to write 2 on the side. So that leaves us with 4. Can I do 4 minus 18? Nope. 4 minus 9? Nope. We're out of quick facts, which means this 4 would be considered our remainder. And then 100 plus 2 is 102. So our answer is 102 remainder 4. The problem is that's not going to be an option. If it was multiple choice like a state test, they wouldn't give 102 remainder 4. They would give options like 102, 106, 103. They would give options that toy with the remainder, so the kids have to figure out what to do. So I will have next week a follow-up video, really diving in depth on division and interpreting remainders. But for today, quick overview. There are 3 ways you can interpret a remainder. You can round it, you can drop it, and you can share it. Share it is what you do when you divide something into pieces. Think sandwiches, pieces of rope, things that can be logically split into pieces. You wouldn't split a bus into pieces. You wouldn't cut a student into pieces to go on a field trip. So share it is pretty easy to know if you're using it or not. The answers to share it also show up as either a fraction or a decimal. Drop it. This is when you drop either the answer, like 102, or you drop the remainder. You drop it when you have to have equal groups. So a lot of times for drop it, they'll use the vocabulary in the problem saying that they are equal groups. They'll be very specific. Round it is when you can't leave something out. For example, if you're going on a field trip, you can't leave a student back behind at the school. You're going to have to take a whole nother bus or a whole nother chaperone for that student. That student might be the only person in the group, but that's okay because you have enough chaperones for the students. Or there might only be 3 students on a bus that could seat 50 people. It's not convenient, but that is okay because you can have empty seats, you just can't leave students behind. For this problem right here, they told us that they must have 9 M&Ms on top. That means we can't have a cookie that only has 4 M&Ms. We can't just make one more cookie because it must have 9. So this would be a drop it problem. So we would drop the remainder. So our answer would be 102. And then we would come right back up to our question to find the label. So it's 102 cookies are finished. So finished cookies. I would also, at the end of this problem, take this as the opportunity to teach my kids how to check their work. They frequently sit back and go, oh, okay, I don't have to check it. They're going to tell me if it's right or wrong. They don't know how to check it. I've also found that, especially during a test, if a student finishes really quickly, I'll be like, okay, well, did you go back and check your work? And they'll nod to me, or they'll go back and they'll scan the page or the screen and flip, 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 or click, 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 depending on what kind of test you're giving. They'll quickly be done and say, yep, I checked. They don't understand what you mean by check. When we're solving, we can do the opposite operation. So we could take 102 times 9, and our answer, if we did our math correct, would have to be 918, and then you had a remainder of 4, so you'd have to add the 4 back in, and that would give you 922. You could also teach, if they've learned more than one strategy for the operation, like multiplication, we learn multiple strategies. You could teach them to use a different strategy to check using the same operation. So maybe they multiply using the box method, and then they turn around and multiply again to check it using partial product algorithm. Using another strategy or using an opposite operation are 2 great ways that I've taught my kids to check their work, and it really makes a big difference. It helps keep them from rushing through a test because they know if they're done in 5 minutes, they do still have to solve them all again a second time. And they know that I'm looking to see that work. If they say, yes, I've checked, well, where is it? Can you show it to me? And so that really has helped force them to slow down and really take their time on tests. And it's been empowering for them to know, like, oh, I made a mistake, but they catch it themselves. If you catch your own mistake, you can still fix it. The test maker doesn't know. Your score is not affected. You can show exactly what you know by catching your own mistakes. And so it's kind of helpful for the kids to see that. All right. Well, like I said earlier, please tune in next week. We're going to talk a little more about division problems specifically, focusing in on interpreting remainders and knowing what to do when. If you like this video, please click that little subscribe button and the thumbs up. Let me know what you like, any questions you have, and I will see you guys next week. Bye.